Hi, this is a video for DCC 4 about our electric pressure model and using multiple representations. There are two phrases here that are really important that will come up over and over again. One of them is this word model, which I'm going to underline, and the other is this phrase multiple representations. This is the first time we're seeing both of those words, so I'm going to explain how they work. So we have been using an electric pressure model, and this definition says a model is a simplification that is useful for making predictions. All models are only sometimes useful, and all models have limitations. Whether a model is useful or not depends on whether it makes useful predictions. That is, for this model, does it help predict brightness? The test of whether a model is useful for us here so far is, does it help us predict whether bulbs are going to light up and how bright they're going to light up? Moving on. Diagrams, equations, graphs, even descriptions with words are all examples of representations. Making good predictions using models requires that you check multiple representations. Multiple meaning many, representations meaning, in this case, a lot of diagrams, and very, very soon, some algebra that we're going to use. So you need to check many diagrams to make sure they are consistent with each other. That's what we're going to talk about here. Notice this symbol is telling us, go ahead and look back. I've got my papers over here. Look back at DCC 1 and DCC 2 and DCC 3. Use your notes as you think about how to do this. Whenever you see one of those symbols, that's telling you go look at those sections to see how they work. So I'm going to give you some suggestions here of some steps that will help you use representations to make good predictions. There's a lot of writing here, so if you don't feel like writing a bunch, you could choose to write down only the things that are helpful for you. But if you're a little shaky on things, I would recommend taking the time to write it all out. There is a lot to write though, so you want to make sure that you leave room. Try to write efficiently. I'm going to start out with this suggestion, put 3 stars by it and say, always work in pencil. So you can erase, and modify, or actually I'm going to say erase and revise your work. You can work in pen if you want to, but you're going to end up making a mistake like we all do and scribbling things out. You can tell, by the way, up here, I made a mistake when I just underlined this word and I had to erase it. And then I started making my video again. I will always work in pencil because I know that I'm going to make mistakes. Step 1 in solving these problems, I would say, annotate any electric pressure you can. Remember, pressure doesn't change across wires. So you can go through, and if you see an H connected to one side of the battery, like this, for example, you can go through and connect that H to here and here and here. As long as it's connected by wires, you can connect it to any place that doesn't have a bulb in the way. That's step 1. Step 2. Draw current arrows. And think about how current might split up among paths. In DCC 3, we saw current split up among paths. Some of the current went here, some of the current went here. Or in this example, half of the current went through one bulb on this path, half of the current went through another bulb on this other path. You need to pay attention to that when you're annotating current. Step 3, check. This is the big step. Actually, I'm going to put some stars by this because you know how much I love to show stars to indicate how important this step is. Check that current and pressure difference are consistent for every bulb. That is, more current means greater pressure difference. I'm just going to write PD there. And I'm going to remind you to look at DCC 2. The last step here is actually the hardest step, I'd say. And it goes like this. If something isn't quite right, play with your current arrow length and pressure values. Oops. Until they are consistent. So what we mean by consistent means, again, more PD equals greater current. So a pressure difference from, let's look at this example again. A pressure difference from high to medium and medium to low would be the same pressure difference. So you would see the same current arrow through both of these bulbs. But a pressure difference from high to medium high is a small difference, and a pressure difference from medium high to low is a big difference. So you would have to see more current through this bulb than through this bulb. A greater pressure difference from medium high to low means more current, a longer arrow. And in fact, we could see, we didn't annotate current on this, but you could if you wanted to. The current splits up, like the current comes out of the battery and it splits up. Half of it goes through this bulb and half of it goes through this bulb. That's why these two bulbs were less bright than this one, because all of that current has to go through this one bulb. Let's finish this up here. The last step here, step 5, would be use current and PD to predict brightness of bulbs. And I'm going to put a couple stars by step 4 as well, because these two steps can take a while. You may realize that something isn't right, and then go back and change it, and then realize that something else isn't right, and then go back and change it. So actually, there's an arrow here kind of going up and saying like, okay, you have to do that again and again and again until it's correct. You don't get to stop doing this until you see that they're consistent. Then you get to make your predictions. So practicing this step, and again, working in pencil, is the best way to get the hang of it and make sure that your predictions are always correct.